All right, this is the start of chapter 4. This is section 1, radian and degree measure. So we're going to start off with some vocab. Trigonometry is derived from the Greek language meaning measurement of triangles. So if you're wondering what to write in your notes, boom. Expanded now to view the classic trigonometric relationships as functions with the set of real numbers as their domains. This includes sound waves, light rays, planetary orbits, vibrating strings, pendulums, and orbits of atomic particles. All sorts of things can be modeled using trigonometry. So, some more vocab for us here. All right, an angle is created by rotating a ray about its endpoint. So, rotating a ray about its endpoint. A ray, remember, has an endpoint and goes forever in one direction. If I just rotate it a little, boom, now I've formed an angle. The initial side is the starting position of that ray. So in this picture I just drew, the initial side would have been this starting side that I started with. The terminal side is the position of the ray after rotation. So that is that ending side there. The vertex is the end point of the ray. So right there is our vertex. Standard position is when an angle is placed on the coordinate plane so that the vertex is on the origin and the initial side lies on the positive x-axis. So initial side is right there on the x-axis. The terminal side is wherever else. I guess vertex on the origin, initial side on positive x-axis is what you're writing in. Positive angles are generated by counterclockwise rotations. So I start here, I open that way, that is a positive angle. Negative angles are generated by clockwise rotations. So if I start here and I turn this way, that's a negative angle. Coterminal is the word for angles with the same initial and terminal sides. They start and end in the same place. Measure of an angle is the amount of rotation from the initial side to the terminal side. In the past, you've probably measured angles in degrees only. But in pre-calculus, we start talking about radians. A couple pictures here. Let's see if I can refocus this a little. I don't know if that's any better, but all right. So for positive angles, we have initial side opens counterclockwise, terminal side. Negative angles, initial side opens clockwise, terminal side. Coterminal angles, they start and end in the same place. A, or alpha, would be a positive coterminal angle. B, or beta, is a negative angle, but they are still coterminal. A reminder, these are symbols that we use a lot in trigonometry. The A-looking one is alpha. The B-looking one is beta. The 0 with like a little extra swirly is theta. All right, another way to get coterminal angles. A is just that initial angle. B goes all the way around and then to that terminal side. Those are also coterminal angles. So now, important word, radian measure. 1 radian is the measure of a central angle, theta, that intercepts an arc, S, equal in length to the radius of the circle. There are just over 6 full radius lengths in a circle, which is 2 pi to be exact. So the definition of 1 radian is an arc on a circle equal to the radius. Okay? This angle is 1 radian if that arc is equal to the radius. We measure radians usually using a pi. So we'll have lots of pi's in them. Some common angles for us. 30 degrees is pi over 6 radians. 45 degrees is pi over 4. 60 degrees is pi over 3. 90 degrees is pi over 2. 80 degrees is pi. 360 degrees is 2 pi. So if you were looking at coordinate plane, we always think of this circle. We'll talk about this circle in a future lesson, not too long. But if I start here at 0 radians, 90 degrees is pi over 2. 180 degrees is pi. All the way around is 2 pi in radians. So some important pieces in the coordinate plane. In quadrant 1, your angles are between 0 and pi over 2. Those are your acute angles. In quadrant 2, your angles are between pi over 2 and pi. Those are your obtuse angles. In quadrant 3, we have angles between pi and 3 pi over 2. Those don't have a special name. And in quadrant 4, we have angles between 3 pi over 2 and 2 pi. Again, no special name. Coterminal angles. Any angle has infinitely many coterminal angles. To find coterminal angles, we simply add or subtract 2n pi, or n times 360 if we're in degrees, from the angles measured where n is any integer. So I could add 2 pi, 2 pi, 4 pi, 6 pi, 8 pi, or I could add 360 or 720, on and on. Or I could subtract those numbers too. So to find a coterminal angle, with 13 pi over 6, let's subtract 2 pi. Remember that to subtract these, we need a common denominator. So 13 pi over 6, 2 pi is 12 pi over 6. So we're left with just 1 pi over 6. Pi over 6 and 13 pi over 6 are coterminal. 3 pi over 4. Let's add 2 pi this time. Since it's not specifying which one to do, we can choose. So 3 pi over 4 plus 2 pi is 8 pi over 4. So I get 11 pi over 4 is a coterminal angle. And for negative 2 pi over 3, we don't usually deal with a lot of negative angles, so let's add 2 pi to this one too. So negative 2 pi over 3 plus 2 pi is 6 pi over 3. So we get positive 4 pi over 3. That's going to be a helpful thing. Things that are big and small, we might want to add or subtract 2 pi and get coterminal angles. So let's do the same thing with degrees. 30 degrees. Well, to get a coterminal angle, we should add or subtract 360. Let's subtract. 30 minus 360 is negative 330 degrees. That is a coterminal angle. At this point in time, that doesn't help us with anything, but it is. Negative 135. Let's add 360 to this one. We get 225. That's my mental math. Let's see. Negative 135 plus 360, 225 degrees. And those are coterminal angles. They start and end in the same spots. A couple more vocab words. Complementary are two angles whose sum is pi over 2. If we're rocking degrees, though, remember that is 90 degrees. Supplementary is two angles whose sum is pi. Remember in degrees, that would be 180. So complementary angles make a right angle. Supplementary angles make a straight line. So if I want to find the complement and supplement of 2 pi over 5, well, complement is 2 pi over 5 plus, let's call it C, equals pi over 2. All right, well, I'm obviously going to subtract that 2 pi over 5. So we have pi over 2 minus 2 pi over 5. And that pen is running out. So now I need a common denominator, right? Let's go 5 pi over 10 minus 4 pi over 10. Our complementary angle is 1 pi over 10. For our supplementary angle, 2 pi over 5 plus s equals pi. We'll do the same thing. We'll take pi minus 2 pi over 5. Get a common denominator, so I have 5 pi over 5 minus 2 pi over 5. My supplementary angle is 3 pi over 5. Not every angle will have a complement and a supplement, though. If they're too big, they won't have both. So let's find the complement and supplement of 4 pi over 5. So 4 pi over 5 plus c makes pi over 2. We'll have c equals pi over 2 minus 4 pi over 5. So I'll get a common denominator. I have 5 pi over 10 minus 8 pi over 10. Our complement is negative 3 pi over 10. I mean, kind but technically that means there's no complement. If the complement has to be a negative value, then there's no way that it actually adds up correctly. For our supplement though, 4 pi over 5 plus s equals pi. Same thing, s equals pi minus 4 pi over 5. Get a common denominator, 5 pi over 5 minus 4 pi over 5. Our supplement is pi over 5. Notice that in all of these, we kind of treat pi like it's a variable. We treat it just like we would with an x. And then we leave it in the answer. We know that pi is just a number, 3.14159, blah, blah, blah. But by treating it like an x, we can leave it in our answer, and that is more helpful as we move forward. So now let's talk about what you're familiar with. You're familiar with degrees. 1 degree is equal to a rotation of 1 over 360 of a complete revolution about the vertex. That's the definition of a degree. It's 1/360th of a rotation. Why did they choose 360? Who knows? Someone chose to call it 360 degrees, and now we deal with it. So we want to convert. Converting between degrees and radians. We can multiply by my degrees by pi over 180. To convert radians to degrees, we can multiply our radians by 180 over pi. But remembering that pi radians equals 180 degrees makes it a little easier if we just remember a single proportion. Radians over pi equals degrees over 180. If you just remember this one proportion, you plug in what you know, find what you don't. So let's try. We're going to convert to radians. So radians is what I'm looking for, over pi equals degrees, which is 135, over 180. To get the radians, I just multiply my pi over, and then we just simplify this fraction. Remember that your calculator can do that for you. If you type in 135 over 180, if you hit math, and then that first answer, or first option, it simplifies to 3/4. But the pi is in there, so remember that it would be 3 pi over 4. Our standard way of writing a measure in radians, put the pi in the numerator, 3 pi over 4. Leave it as a fraction, leave the pi in it. So for 540, radians over pi equals 540 over 180. We multiply our pi over, and then we just simplify the fraction. 540 over 180 simplifies to 3, so our radians here are 3 pi. We also don't usually put a label on radians. Sometimes we put a label just to emphasize that it is radians, but otherwise, just like this, we assume it's radians. All right, radians over pi equals negative 270 over 180. Multiply my pi over. Simplify negative 270 over 180. We get 3 over 2, negative 3 over 2. R equals negative 3 pi over 2. There's our radians. All right, now I have a few that I'd like you to try, but I'll walk through them here since it's our video. We go radians over pi equals 175 over 180. Multiply my pi over. So my radians, simplify 175 over 180. Turn it into a fraction. Oh my, pushing wrong button. Sorry, 175 over 180. Math, frac. Okay, 35 pi over 36. Radians over pi equals 82.8 over 180. Multiply my pi over. 82.8 over 180 simplifies to 23 over 50. Stick that pi in the numerator. There's our answer. Radians over pi equals negative 57 over 180. Multiply that pi over. 57 over 180. Negative 19 pi over 60. All right, a few more for you here. Again, you will try these on your own. For 210, radians over pi equals 210 over 180. Multiply the pi. We get 7 pi over 6. Radians over pi equals negative 135 over 180. Multiply that pi over. We get negative 3 pi over 4. And radians over pi equals 590 over 180. Multiply that pi over. We get 59 pi over 18. All right, now let's convert the other way. We're going to convert into degrees now. And this looks a lot more complicated than it is at first. So we take our radians, negative pi over 2, over pi, equals degrees over 180. The nice thing about this is that if there's a pi in our radian measure, these pi's actually cancel, leaving me 1, negative 1, over 2 equals degrees over 180. Notice that it's still leaving me a 1 here with where the pi was. We multiply our 180, and our degrees is negative 90 degrees. Make sure in degrees that you label it. So if I have 9 pi over 2 over pi equals degrees over 180, when I cancel my pi's, I get 9 over 2 equals degrees over 180. Multiply my 180. I get 810 degrees. 2 radians. This is the time when you will usually put radians on there if there's no pi involved. So we have 2 over pi equals d over 180. We can't simplify out a pi, so we just multiply the 180 over. And now it's a calculator problem. 180 times 2 divided by pi. Our degree measure is about 114.592 degrees. All right, these ones you would try on your own, but let's walk through them. For pi over 3, we take pi over 3 over pi equals degrees over 180. Those pi's cancel, leaving me 1/3 equals degrees over 180. Multiply that 180, and we get pi over, wow, losing my mind, sorry. We get 60 degrees. There we go. 25 pi over 40 over pi equals degrees over 180. Those pi's cancel, leaving me 25 over 40 equals degrees over 180. Notice 25 over 40 could simplify, but it doesn't matter because that's not our final answer anyway. Multiply by 180. 180 times 25 divided by 40. Our degree measure is 112.5 degrees. And for 6 radians, 6 over pi equals degrees over 180. This is one where you'll just multiply the 180. 180 times 6 divided by pi. We get 343.775 degrees. All right, a few more for you. All right, to convert these into degrees, we take pi over 12 over pi equals degrees over 180. So we get 1 over 12 equals degrees over 180. Multiply that 180 on both sides. We get 15 degrees. Negative 4 pi over 3 over pi equals degrees over 180. Cancel those pi's, we get negative 4 over 3 equals degrees over 180. Multiply by 180. We get negative 240 degrees. And 25 pi over 6 over pi equals degrees over 180. Cancel those pi's, we have 25 over 6 equals degrees over 180. Multiply the 180. We get 750 degrees. All right, so converting, hopefully not too terrible. Now let's do some applications. Reasons we care a lot about radians. For a circle of radius r and a central angle theta, it intercepts an arc of length s, given by s equals r theta, where theta is measured in radians. So if I want to find the length of this arc here, that's s, I take the radius times theta, but theta has to be measured in radians. So, start off pretty straightforward. Find s if r equals 6 and theta equals pi over 8. So we will s equals r, which is 6, times theta, which is pi over 8. 6 times pi over 8 is about 2.356. And since we're measuring in inches, we label it inches. Now we're going to work a little differently. Find theta if r is 10 and s is 30.55. So s is 30.55 equals r, which is 10, times theta. Divide both sides by 10. Theta equals 3.055. This is a time when labeling it radians is probably a good idea, but there's our answer. Find s if theta equals 220 degrees and r equals 9. Here's an issue. We can't do 9 times 220. Theta has to be in radians. So radians over pi equals 220 over 180. Multiply by pi. And simplify. Oh, let's call that radians so that I don't get confused with my other r. 220 over 180, it becomes 11 pi over 4. Now we can find our arc length. A radius of 9 times 11 pi over 4. 9 times 11 pi over 4 is about 77.754 inches. Now let's find r if s is 25.7 and theta is 105. Well, right away, if we are finding arc length, we need theta to be in radians. So radians over pi equals 105 over 180. Multiply that pi over. My radians is 7 pi over 12. Now we can go into our arc length formula. 27.5 equals my radius times 7 pi over 12. To solve here, we're going to divide by 7 pi over 12 or multiply by its reciprocal, 12 over 7 pi, on both sides. When you do this in your calculator, though, please be careful. We need 27.5 times 12 divided by, if I just type 7 pi, I'll get 148. That's not the correct answer. What you need is parentheses around that denominator, because 7 pi is not a single number, it's 7 times pi. The first line here, we'll divide by 7 and then multiply that answer by pi. The bottom one multiplies the 7 pi and divides by that whole thing. So the answer is actually 15.006. Very big difference. Our radius is 15.006 centimeters. And another application is the area of a sector. A sector is just like a part of the circle. So for a circle of radius r, the area of a sector, so this whole thing, right, that area, with a central angle theta, is area equals 1/2 r squared theta. Theta has to be, again, in radians. So 1/2 r squared theta. So a sprinkler rotates through an angle of 120 degrees and sprays water a distance of 30 feet. Find the amount of area watered. Well, our angle is in degrees. So radians over pi equals degrees over 180. Multiply my pi. My angle is 2/3, or 2 pi over 3. All right, it sprays at a distance of 30 feet, which means that's our radius. So the area equals 1/2 times the radius of 30 squared times my angle, which is 2 pi over 3. Now we just type that in our calculator. 1/2 times 30 squared times 2 pi over 3, 942.478 feet squared. Make sure it's squared because it's an area. And a rear windshield wiper runs through an angle of 90 degrees. Well, 90 degrees is one of those common angles. It's pi over 2. The total arm and blade is 23 inches long, and the blade itself is 14. What's the area cleared? So if you know anything about your windshield wiper, right? It does this, but then it misses this part. So pretend I drew actual circles there. This whole arm and blade is 23 inches long. The blade itself is this part here, which is 14, which means this inner circle has a radius of 9. So if I want the area cleared, that's this top part. So I take the whole area minus that inner part. So the whole area, we'll call it A1, 1/2 times radius, which is 23 squared, times my angle of pi over 2. We'll get that answer in a second. But then we want A2. A2 is going to be this inner part. That area is 1/2 times 9 squared times my angle of pi over 2. And then I'm going to subtract them. A1 minus A2. Big area minus little area. So let's get our answers. 0.5 times 23 squared times pi over 2. Let's just dive straight in and subtract them. 1/2 times 9 squared times pi over 2. I get about 351.858 inches squared. Remember, area always labeled squared. All right, your assignment on this, lots of problems to practice with because lots of practice is needed to get really good at it.